All right, so let's talk about evaluating an algebraic expression. We're going to take this problem here, evaluate each expression if x equals 3 and y equals -1. Now here we have a, here, so we got x plus, all right, let me erase this. We got x plus 3y. Now here we need to use substitution here. So x equals 3 and y equals -1. So it means we're going to substitute x by 3 and y by -1. Make sure you have parentheses here so we can distinguish between positive and negative. Now here we have 3. No, positive times negative is negative, will be 3. So 3 minus 3 will be 0. So the answer will be 0. Okay, so it would be 0. Okay. The answer here would be 0. And then we have b. We have 5xy. So here we're going to substitute x by 3 and y by -1. Again, we have 5 times 3 is 15 times -1. Now, positive times negative is negative, and 15 times 1 will be 15. So the answer will be 15. So this is minus 15 for B. And then we have C. We have 3y over 2 minus 2x equals, well, 3, we will substitute y by -1 again, and 2 minus 2x, well, let me erase this. No, x, we're going to substitute x by 3. So x will be substituted by 3, so will be 3 here, okay? And then -3 over 2 minus 6 here. We got 2 minus 6, and here we have -3 over -4. Now, negative over negative will be positive, and here we have here 3 over 4, right? I will discuss the multiplication and division of the signs after this problem. Here we have D. Now D, the absolute value of -4x plus. So here we have x is equal 3 and y equals. So the absolute value of -4x plus y. Okay, let me make sure we got this. We have so -4. No, x is equal. Well, x is equal. So we substitute x by 3 plus -1, -1, right? Now, it would be a good idea if we can add parentheses when we have negative signs, so we can make sure to avoid the problem of addition and subtraction here. So -4 times 3 would be -12 minus 1, and here we have -12 minus 1 would be -13. Again, as we discussed before, the absolute value represents the distance, how far -13, how far from 0. So if we were going to count the number of units, so the absolute value is a distance, will be always positive, right? The absolute value is always positive, so would be equal to 13, right? Let me just discuss the multiplication and division of the sign. Well, let's talk about multiplication first. Here we have, if we have negative times negative, will be positive. If we have positive times positive, will be positive. And if we have positive times negative, will be negative. And if we have negative times positive, will be negative. So here, if you multiply two values with the same sign, we will get a positive number. If we multiply two values with different sign, we will get negative number. Well, the same goes for division. Right? If we have negative value over negative, will be positive. If we have positive over positive, will be positive. And if we have positive over negative, will be negative. And then negative over positive will be negative. If you have like a, let's have an example here. If you have like a -2 times 3, now negative times positive is, so we're going to use this, right? So there will be -6 here. If you have like -3 times -4, again, negative times negative is what? It's positive. So that will be positive 12, right? The same for division. Like let's suppose we have -9 over 3. So negative over positive is positive, is negative, so there will be negative 3, right? And let's suppose we have negative 6 over negative 2. Now negative over negative is positive, we're going to use this one here, okay? And that will be 3, right? And that's it for today. Have a good day. Okay, yes. Let's get this example here. Okay. So the definition, the set of values of that variable may assume is called the domain of the variable. Well, let's take this example, finding the domain of a variable, and we have 5 over x minus 2. Well, let's write it in a different way here. We get like x, so let's call this one as a function, and x is the input, so y will be the output. Now the domain here, that the denominator should be different than 0, means x should be different than 2. It's like we're going to solve for 2. We're going to solve for 0. So we're going to move negative 2 to the right, and we'll change the sign, so x should be different than 2. So it means all values from negative infinity to 2 and 2 to positive infinity. So we can take any number, we can take any values, right? Any value, we can substitute x by that value except 2. For example, let's suppose here we have x equals minus 2. Yeah, it's okay. So we're gonna 5. We're gonna solve this expression, algebraic expression. So we have negative 2 minus 2 here. So negative 2. We're gonna add two values with the same sign. We're gonna just have the sum of the values here, which is 4, and both of them are negative. We're just gonna add negative. So the output here, y, it's 5 over negative 4 or negative 5 over 4. You know, it's the same thing. For example, let's have x, let's solve for x equals 5, right? So here we have, let me change the sign, let me change the color here. So let's suppose x equals 5. So here we have 5 over 5 minus 2, and that would be 5 over 3, right? So we can pick any value except 2. So 2 must be excluded from the domain. Okay? Alright, see you to the next video. Alright, so today we're going to talk about domain. So the domain of a function, of any function, is a set of values, of input values for which the function is defined. Right? So when we have like 1 over x. Now here, the condition that x should be different than 0, because 1 over 0 is undefined. It's undefined. Okay, so x is all values from negative infinity to 0, and 0 should be excluded from the domain. Right? So the domain is all values except 0. So x should be different than 0. Well, sometimes we have the square root of x. Let me just okay. Now sometimes we have the square root of x. Let's see. Okay. Now, so here, well, the domain of the square root consists only of numbers greater than or equal to 0. I mean, here x should be greater or equal to 0. Okay? Because we can have square root of 0 equals 0 here, right? We can have square root of 4 equals 2, square root of 3. All these values, it does exist. We can have output. By the way, when we call x, now x here is called input. We're going to discuss this more when we study function, right? And the output, for example, square root of 4 is 2. If this is the input, so 2 will be the output. So the point is, if we have a set of input values for which the function is defined, I mean, we can have a value of output. We can have y. So sometimes we call it y, like y equal, like let me change color here. Like for example, we have y equals square root of x. Now we enter x as input and we get y. If we cannot get y, means something is wrong with x. Means x is excluded from the domain. So we want to make sure that we have all the values that we can have y exist, right? So this is the point. Well, let's sometimes we can let's add another example. Sometimes when we have 1 over square root of x. Well, here we have two conditions. We have x inside the square root, and it's located in the denominator. Now, the denominator should be different than 0, and inside the square root should be positive, right? So the thing is, x should be greater than 0. Not equal to 0, of course, right? Because if we have equal 0, we're going to have 1 over square root of x, 1 over square root of 0, which is 0. So 1 over 0 does not, is undefined. So here, we have all values from 0 to positive infinity. This is interval notation. This is called interval notation. Sometimes they will ask you to grab the solution, right? And we discussed this before. If we have 0, 1, 2, 3, here we have negative 1, negative 2, negative 3. So all values, the domain is all values from 0 to positive infinity. Right? Let me have, let's see here. Let me have this example. No,